Shout out to King's Quest 7. Was that the Mask of Eternity? Because that had a bug in it for me, and I couldn't get past the underworld because the game would freeze every time I went through. What do you make of Sam Harris's recent comments? I think you're referring to Sam saying that he didn't care if Biden's son had dead children in the basement. He still would vote for him. It just shows you the extreme lengths of Trump derangement syndrome. That's okay. Sam is pretty upset about the whole Trump era. He's the antithesis of everything he stands for. Charles, what are your thoughts on the top person in longevity medicine and why? Probably at the moment going to be David Sinclair. He not only has a long track record at Harvard of great discoveries and great knowledge, he's a very effective communicator with his podcast, his book Lifespan, and he's a good collaborator. He works very well with other people. And the approach that he's taking, he's basically saying, it's not necessarily that we lose information in the hardware, so the DNA side. And the argument he has, you can take DNA from an old creature, clone it, and make another creature with that, and they go through the entire life cycle. It's information loss in the epigenome. And there's more to the story. Aging is caused by a variety of factors. It's a complicated topic, but the long and the short is that there is some notion of deterioration in how your body maintains protein homeostasis. There's a deterioration in telomeres. There's a deterioration in where senescent cells are just floating around and they're not being cleaned up properly. Stuff just starts breaking down. And there's plenty of books about this. Like Aubrey de Grey was one of the formative people in the longevity and anti-aging movements in the 2000s and 2010s, been mostly replaced by Dave Sinclair at the moment. And I think Dave is onto something, because what he's been doing is he's been cloning mice, and he's doing something to one mouse and nothing to the other mouse. He's leaving it as a control. And then real time, you watch one mouse get old and the other one stay younger. That's pretty compelling, because they're genetically identical and they're in the exact same environment, the exact same circumstances, the same diet. It's really hard to get a better control than that. And there are creatures in nature that seem to have the ability to rejuvenate themselves. Salamanders have tremendous regenerative capabilities. There's jellyfish that live forever. They form a cyst and then they go back to the polyp stage, and then they become a medusa again, and they can go back to polyp and so forth. And at the end of the day, a lot of the things that Dave is saying are saying, well, life had two tracks, a time of abundance and pleasure and a time of scarcity and pain. And when it's abundance and pleasure, be fruitful and multiply. And then once you've multiplied, die off. When you're in pain and scarcity, you don't have the ability to multiply. It's evolutionarily counterproductive. So instead, turtle up and live longer until you have the other condition, then be fruitful and multiply. So a lot of the techniques that they're using for anti-aging involve stressing the body in clever ways. And you have different pathways from like mTOR and these types of things. And so Lifespan's a great book. And there's a lot of really good information there. And ultimately, it's nothing revolutionary if you happen to be a person inside the field, but it is very eye-opening that aging is effectively a process that we're starting to actually understand, to the level where we may actually be able to do something about it, not just slow it down, but also rejuvenation. So this has led to my fascination with hyperbaric chambers, because there's a company called Aviv Clinics that's using them for rejuvenation, and they've had phenomenal results. And it's also led to my fascination of cell-based programming, where people are like companies like BitBio, for example, are trying to figure out a language, a chemical language for cells. And if you expose the cells to the right things, you can actually turn them back into other things. So there was a Japanese scientist who got a Nobel Prize in medicine who actually figured out the chemical compositions to take a cell and turn it into another cell. And later derivations of that work led the ability to turn a cell into a stem cell. So you could take like a skin cell and turn it into a heart cell or to a liver cell or to a brain cell and so forth. And it indicates that there is a chemical programming language for these things. And hypothetically, if you understood it, you'd be able to program cells in just the right way to do things like kill themselves or multiply or rejuvenate and these types of things, which would be great for the treatment of cancer. And there's a lot of amazing stuff that's happening there. Dave actually used these techniques in his lab to restore eyesight for an old mouse. And it was really clever. Now, you have to be really careful with it, because if you revert cells back to these proto states, you probably give people cancer. So it's a very complicated field, and there's a lot of moving pieces. And some of you know that I own a company that is starting to get involved in this field, and we're approaching it from the clinical side. So we're starting with a health and wellness center, lots of doctors, some in functional medicine, some in internal medicine, some in family practice, some genetics experts, a clinical pathologist, these things. And we have a full lab, a CLIA-approved lab, and compounding pharmacy, and a lot of very sophisticated diagnostic equipment, including a full genome sequencer, so we can do a full body genome, a full human genome sequence, for lack of a better term. And the goal is in just a few years to really replicate and understand a lot of things that Dave is doing at his lab. And also what Peter Diamandis is talking about. He just wrote a book called Life Force with Tony Robbins and Dave Asprey and a lot of the other people that are very interested in this field. We'll at some point probably start manufacturing exosomes or stem cells, and then trying to figure out ways that they could actually be used in experiments to see if there's actually something there. I think stem cells and exosomes are part of the question, but they require the instruction set. It's kind of like having Lego bricks around. You need somebody to still build the Lego in order for the Lego to be useful.